Okay. Alrighty, so let me just make sure. Okay. Okay, so this week, as I mentioned before, we're going to continue our conversation about rigging. Specifically, we're going to drive in to the entire system of constraints today. We actually just explored our first constraint last week in the parent-child relationship. Well, the parent-child relationship is the most basic and the most simple constraint that we have access to working with inside of Modo. Today we're going to talk about some really neat ones like the position constraint and the direction constraint and the path constraint. Ultimately, what we want to have be accomplished here is that we want to have the animation of one element drive the animation of another. We don't necessarily have to animate everything. With some intelligent designs and some forward thinking, we can create small little machines that will allow this interaction to happen automatically in the back end. Okay? It's pretty neat. I think you're going to like working with constraints. It's one of those elements inside of Modo that's infinitely useful. Not even, even on the modeling side. Okay? Of course, constraints, there's a natural application for the animation workflow. But when you're modeling, just being able to make a position constraint or a directional constraint really helps kind of get through this process a whole lot faster. This week's homework assignment is going to be kind of a small, well, kind of a big one. You're going to be doing a project that I love. It's one of my favorites every year. It's called Alien Invasion. Aliens are invading a fictitious city that you're going to create. Defend yourselves! Defend yourselves. This is the one with the cannon, yeah. So we're going to be making a small turret. I've given you the little spaceship that you can see on the screen, and your job is to animate the little spacecraft flying around, maybe attacking your city in one capacity, and then also create a rig and a constraint system that automatically tracks the movement of that spaceship on the turret. Okay? We're only going to animate truly one element here, and that's the spacecraft. The turret is automatically going to track that spacecraft in the sky, and all driven from constraints. It's going to be a fun one. I think you guys are going to like this assignment. More on this later. So this week's conversation, constraints, constraints, constraints. I love constraints. Okay, questions before we get going. There's two things that you'll need to download. One for your homework specifically, and the other for this week's kind of in-class conversation. Here's the spaceship model file. Boom. So download that, save it to your personal library. In addition, inside the root content folder, I've also given you a zipped archive called Working with Constraints. Go ahead and download this if you haven't already. This is the project file that we're going to be using during class to talk about how all of these constraints are going to work together cohesively in Modo. Now, why is it not downloading? No, it did. This drives me crazy about Chrome. Has anyone else run into this problem with Chrome that you download something and it doesn't update the icon? Drives me batty. Okay. Let me open up this project file and we'll begin. Okay, so here's our project file. If we go through and look at all these little pieces here, the item list is really constructed from 3 separate items. Before we start any rigging assignment, and this goes for characters, hard surface stuff, everything, we need to do a deep analysis of the project and the assets that are included inside this project file. What I normally start with is an analysis of the center points. So we have the arrow, the little target, and the big target. Where are we going to be doing all of our rigging inside of Modo? Setup tab. Do yourself a favor. Do not try to do any of these relationships inside of the model tab. There are a lot of extra viewport properties that are turned on in the setup tab that make it a much more useful and streamlined work environment. Let's check it out. Let's go into the setup tab. Aha, here we go. We don't need our schematic for this one, so we're just going to turn that bad boy off. Okay. Let's turn my viewport to the advanced OpenGL shading method. There we go. Now, a couple things about the setup window that's a little bit, or the setup environment, that's a little bit different from some of the other modeling or some of the other OpenGL viewports that we're used to working with. when we have view lights enabled, we're going to start to see the inclusion of shadows inside of our scene. This can get a little confusing. So I almost always, see how we can get the lights now? It's awesome. It's awesome if you're trying to do some texture work or even some modeling, of course, animation. But for us in the rigging world, I usually turn that off because I want everything to be kind of flat shaded. It's going to make seeing my mesh a whole lot easier. Excuse me. Okay. So last week we talked a little bit about creating relationships inside of Modo. Do you remember the first relationship we crafted? The parent-child relationship, right? And the parent-child relationship is very easy to construct. It allows the movement of the parent to influence the movement of our child. Now, before we go too much further, in the animation world and in the rigging world, what is the most important component of our item? Most important thing? The center point. You got it. We have to be laser focused on the location, rotation, and scale of our center point. Now, the Setup tab draws all of the center points for your items automatically. In other environments, it's not going to do this. Specifically, what does our center point look like? Tool handles without arrows. I think we're in the ballpark. Yeah, can you be any more specific? You got it. That little disc in the center. And the tool handles that you're seeing, Van, are just indicators of the local orientation of the X, Y, and Z axis. Okay? So the little disc in the center represents the center point. Now, I need you guys to be very aware that there's a difference between the center point and the pivot point, a difference that we'll talk about in detail when we start working with more complex rigs. The center point is just a pure white disc, okay? A pure white disc. So if you see a disc that has a whole bunch of like crosses on it, you're working at the pivot point, and you don't want to work on the pivot point, okay? You want to work on the center point. Up at the top of the screen, the Setup tab allows you to select a whole series of additional elements. Of course, we're working with items, but there's the pivots and there's the centers. So now I can very quickly go in, select that center point, and transform it to anywhere I want in the scene. Now, I'm very, very happy with the location of this center point. It's perfectly centered around the middle of that big target. Okay, very happy with that. Let's just do an analysis real quickly of all the other items inside of our scene. So there's the big target, there's the little target, awesome, and there's the arrow. Now, all three of these items have a consistent location of our center point. What is that location? The origin of the scene, okay? All center points, and this is something that we really kind of need to jump up and down about. All center points are going to be initially created at the origin of our scene. So if you can't find your center point, look at the origin. It's more than likely going to be there. So it's something we got to kind of keep our subconscious and our eyeballs focused on. All right. I'm going to go into item mode and start moving some of these elements around. And we're going to create just a very, very simple hierarchy here. I'm going to move this guy way out over there. Split the difference here. Cool. Okay, so there's my three elements. FYI, I'm going to turn off the grid. For me personally, I don't like having the grid on when I'm working in the Setup tab. You know, we should be comfortable enough inside this 3D space to not rely on the grid to help us figure out our spatial kind of orientation. Also cleans up our work environment a little bit. Draws focus to all the stuff, all of our items. Okay, so I want to create a little hierarchy here. So I'm in item mode. There's my arrow. There's my little target, and there's my big target. Now, I want the big target to be the driver, to be the parent of all of these other elements within the scene. I want to parent my little target, that little ring, to my big ring. How do I do this? So we can do it with drop actions. That's a good way of doing it. Let's revisit that idea. At the top of our setup interface, we have this drop action pull-down menu, and this is pretty fantastic, okay? because now we can parent elements inside the OpenGL viewport just by dragging and dropping them on each other. So I can grab my little ring, drag it on top of that one right there, boom, we've parented. In addition, check it out. Look at our item list. We're now creating a visual hierarchy of elements inside of our scene, and this is good, okay? This is our parent-child relationship at play. Parent-child relationship, as discussed last week, allows us to have the parent, the most top level of our hierarchy, influence the transform, and just the transform of all of the items that are below it inside the hierarchy. So wherever I move the big target, the little target should also move. Just grab this guy. There we go. Since the relationship is in play. Yeah, there we go. I'm going to rotate this guy. Whoa, 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 whoa. Awesome. Even scale him up, and everything is going to work. Okay? Just the transform elements of these two elements are going to be influenced. Just the transform. So position, rotation, and scale. Now, since I've made this relationship, am I locked out of animating and working with that little target? No. This is the great thing about parent-child relationships. The parent's going to drive the transform, but the child can still move independently from the parent. It gives us multiple degrees of animation. And I'm going to sneeze. Maybe. Oh, I hate that feeling, right? Oh, it drives me crazy. It drives me absolutely batty. Okay, here we go. Let's keep going. So this is all really kind of neat. So I can, as an example, just grab my big target here. Whoops, excuse me. Let's try that again. And I want to animate let's just animate the rotation channel here. And for 30 frames, I want to animate this going around 360 degrees here. Oops, I didn't hit the keyframe button. Actually, I did position Y. I wanted rotation. That's why I was like, what is going on here? There we go. Whoops. There we go. Let's play our animation. Aha! Fantastic. Looking good. But the cool thing about this is that I can still animate and control the local rotation of the child element inside this hierarchy. So let's do the exact same thing. I'm going to put a rotation keyframe on the y-axis and have this guy also spin 360 degrees. Now it's going to spin around his own local, which is pretty cool. So it falls into the center of, like, right there? Yeah, absolutely. How could we do that? If I want to move my little ring to a different point within the universe. Getting deep? Yeah, you can do it. Probably the easiest way to do it is just to physically animate it, to go that way. Yeah, you can animate it going back to the location of its parent's center point. Let's do, instead of doing rotate Y, let's do rotate X. That might be a little bit more obvious. There we go. Now we're getting two types of movement. The parent's driving animation, but as is the child, their own local animation. Parent-child relationships are extraordinarily powerful. The most, kind of the simplest building block that we have inside of Modo. You're going to be using parent-child relationships a lot. When we start working into character rigging here in a couple weeks, believe it or not, a majority of our skeletal system that we'll be creating is going to be nothing more than a whole series of parent-child relationships, right? And you'll hear me do this, next week. The head bone's connected to the neck bone, the neck bone's connected to the, so on and so forth. It's just a gigantic chain. It's a hierarchy of elements that are all connected to each other, right? Parent-child. Wherever the parent goes, if the parent of my arm is the shoulder, wherever I rotate my shoulder, my entire arm goes, right? But I still, at the bottom of the chain, can move my finger, okay? the child, the smallest child on that hierarchy can be independently moved. Okay. How do I remove a parent-child relationship from our hierarchy? Yeah, you got it. So we can remove it from the hierarchy just by, just by left-clicking in and dragging it. Now, pay real close attention to the location of that arrow. That arrow is going to tell you where within inside of your item list hierarchy that thing is going to go. Yeah?
I'm having an issue with my rotation tool.
Okay.
It's not showing me the handles.
It's not showing you the handle. Let's check it out, Carlos. What machine are you?
11.
11.
I've got the move, the scale, but not the rotation. I had that problem last week with my move.
All right. Let's take a look-see here. So there's scale. Yeah, Ray, you had this problem. I remember that problem coming up. You couldn't find your move handles at all. Now, can you go over to your tool property, or go to the move tool, fire off move. Yeah, go over to, there they are. Yeah. Oh, so it's the rotation handles that aren't showing up. Different. Okay. With the rotation tool on, go ahead and go to your tool properties. Does it recognize? Yeah, so it recognizes that it's a live element. Let's do this. Let's explore this for a second. Go into your lists tab. This may be a bug. See down here in what's called the pipeline or the tool pipe, we have an indicator that the transform tool is on. Where it says V, click on that V in the column right below it. There it is. The visibility of your tool handles got turned off. Ray, that may be the solution for your problem as well. It's a really cool, neat, nifty part of Modo. The tool pipe allows us to make collections of tools, if you will. So if I was to fire off item transform, you can see that the visibility of mine is enabled with that little dot. Yeah. Okay. All right. Yeah. Yeah, and I'm not sure if that was another student who accidentally turned that off, or if it's just it got toggled off randomly during the installation. I don't know, but there's your solution. Okay. There's other ways to create parent-child relationships. Give me another way we can create a parent-child relationship. You got it. We can drag it on to each other in the item list. Boom. That's very, very acceptable. What just happened there? Parenting unparented is not supported for. Oh, I've already have animation on it. Yeah, which makes sense. Here, let's just nuke the animation for these guys. I'm just going to turn that one off. I'll go to the next keyframe. Turn that one off. Put its rotation value back to 0. Same with big target. Now, yep, now it works. All right. There's one other way that we can make a parent-child relationship. I'm sorry, say again? The Action Center? The Action Center, no. This up here? No, definitely don't go into the Action Center. The Action Center is only going to change the location of your tool handles. Yeah, so that's definitely not a place that we want to go to create a parent-child relationship. Inside of our setup tools, we have the ability to make a hierarchy. Okay, so this would be the third way to very quickly create a parent-child relationship, just by clicking on that button, and then there we go. Now, the selection order inside of Modo is really, really important. An element that's going to be emphasized today. Because if you don't select things in the correct order, it's no going to worky. It's not going to work at all, actually. Okay? What is that selection order? Yeah? You got it. You got it. So we're always going to select the child first and then the parent. Watch what happens when I hit the parent button. Boom. Little target now becomes a child of big target. So you always got to select the child first. That's a big, 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 big sequence that we have to honor and follow. Yeah?
That'd probably come in handy
Yeah, absolutely. These drop actions are really cool, but as Ray, you just kind of pointed out, in complex scenes, when there's a lot going on, it may not be the option for us. So, got to be mindful of that. Got to be very, very mindful of that. Okay. In my mind, here's how I kind of have it make sense. I say this one is going to get parented to that one. Child, then parent. Child, then parent. Always select the child first, and then you'll get the result that you're after. Rock and roll. Okay. Questions on what we've talked about so far? Real quick, let's revisit the idea of locators. Okay. Locators are a big part, or are going to be a big part for every single thing that we work with inside of Modo. The rigging universe inside of Modo behaves and operates a whole lot more easily when we use locators at the root of everything that we do. Inside the Modo interface, where can I go to add a locator? Add item. So if you're going in the item list, it is one of the elements that you can create in the add item pull-down list. Let's check it out. Add item, and then there it is, locator. Boom, that's what it looks like. Where's a locator automatically going to be created? At the origin, okay? The center points are automatically created at the origin, as is a locator. It's always going to be placed at the exact same spot, so look for it there. Question? Are you good?
I was going to say, is there any way that the locator is ever created at the center of the
I don't think so. Yeah, we'll have to manually put it there. The default creation location for a locator is the origin of the scene. A locator is an item just like any other item. FYI, real fast, here's another place inside of our toolbar that we can easily create a locator. Okay, don't necessarily have to go back over into the item list to generate one. Boom. Okay. Do locators render? No, they are invisible. Yeah, well, it's going to leave them on when you do RayGL. But if we went to the render tab, yeah, locators are invisible. Okay. They're never, ever, ever going to render. Locators, however, can be displayed a little bit differently inside of our scene. Oh, one thing, and this is important, especially if you're working over in the design lab. As you just mentioned, or excuse me, as you just saw inside of my viewport options, show locators is an option that we can turn on and off. So if you can't find your locators, even though your item list tells you that there's one there, double check your viewport properties. We can disable their their appearance right here in the viewport properties. Okay. All right. Now locators are great. I like working with locators. The easiest way to describe a locator is that it is only going to log the transform of any item, okay, or of itself. So we're not really doing a whole lot of heavy lifting on a locator. It's pretty much just the transform, position, rotation, and scale. Now we can associate the location of this element with a number of different things. You'll see that in play here a little bit later on when we start talking about our constraints. One of the cool things that makes the Modo locator system more powerful than others is that we can easily change the way they're drawn. If I wanted to create a whole bunch of control surfaces for my little ring here, how would I do that? Display. And real quick, let me just back up for a second. The reason why we want to change the locator shapes is often it's very difficult to see and select these locators, right? They're like a 1 pixel line inside of our interface, and that's kind of hard to see at times, especially when you have a whole series of locators that are in a character, okay? We're working with locators outside of very basic geometry. I think starting next week or the week after, we're going to start jumping into working with characters, okay? All of these pieces are going to be on the interior of that mesh. We either are going to see little bits and pieces of our locator coming out or of the mesh, or we're not going to see them at all. So let's change the way they're drawn. So as I think I heard someone say it, the display tab in the properties area is going to allow us to change the way that this element is being drawn inside the viewport. So let's do this. Let's add some draw options. At the very least, it's really kind of neat to know that we can go in and change the colors of these. Let's just use a user-generated color. And I'm going to choose this lovely shade of red. Yeah, and now we're getting some red in there. Awesome. Let's do the fill color as well. Right now, it doesn't have any fill information that is going to drive that value. But once we change over here the locator shapes, then that fill value will come back in. So I'm going to create a custom shape. I mean, this is really, really kind of neat, okay? This is something that is honestly quite special about the Moto rigging system. Let's see, and I'm going to replace this bad boy. Oop, locator shapes. Style, we want to, when the style is on add, we still get the little cross visible within our scene that represents the locator. So I'm going to replace it with this box. There we go. Now that cross is gone. And maybe not a box. Let's do a pyramid. Pyramid's kind of fun. And we can even make it just a wireframe pyramid if we like. Pretty neat. And let's have it aligned to the y-axis. And we can also, let's scale it down some. It's a little bit too gigantic for the moment. We're also going to offset it maybe along, what, the x-axis. Push it off to the side. Now we're ready to rock and roll. Now, a lot of folks, they get a little confused as to the location of the center point when working with locator shapes that are offset from the parent, from the locator. But if you click on it, it's always going to show you the location of the center point, which is the most important thing in the rigging universe, right? That center point. So keep your eyes fixed towards the location of the center points. It's going to give you the information that you need. I'm sorry, I couldn't understand you. So the wireframe. So back inside your locator shapes options, solid, just turn that off. Boing. Circle, I use circle a lot. I like circle. Align to view is kind of fun. Let's get it to the right view. There we go. Now it's always going to face us, and I can just select that bad boy and continue to work with it. If I have my big target parented to this locator, now I can drive the entire animation of this thing where I want it to go. Since the center point for the locator is in the exact same position as the center point for that big circle, they're going to move predictably. Questions?
So if you have just a wireframe instead of fill,
Yeah.
you can only activate by clicking on the line, right? Not the center of the actual outline.
That's correct, yeah. That's a good distinction. When you're in just a wireframe, you got to hover over the little wireframe in order to click on it, which is why I think a lot of folks choose to go with fill.
But you don't have to really click on it. You can like scroll over it like you would scroll over polygons.
Like just hover over it? Is that what you mean?
Like if you click and then hover over it when wireframe, it still clicks on it.
Yeah, I mean it does. I mean, if you do like that, but now, point being, we have a much smaller target.
No, I mean you don't have to like hover the mouse. If you like have your mouse anywhere on the screen, or you can do that, and you click down and then scroll over.
What do you mean scroll over? I think that's where I'm getting confused.
Put the mouse off of it.
Mm-hmm.
If you click now, hold it down, and
Oh, I see what you mean. Yeah, that's dangerous. That's dangerous. It's easy for this environment because we only have a couple things in there, but that's going to be a dangerous kind of workflow when we're working in very complex environments where there's a lot of different assets going on. So, good trick though. Okay. You're going to see me working with these locator shapes a lot. I'm a big fan of them. I try to kind of keep the fill colors a little bit kind of muted. Sometimes we want like really outrageous things, but I like having the wireframe colors be the one thing that my brain kind of picks up on. That's just me. Figure out what works for you. Everyone's going to approach this just a little bit differently. Another great thing, you can also change the size. Now we have the, if I put this back to add, inside the 3D items, the size value here is going to determine the size of that cross. And that's something to note as well. Some folks really like having that cross in their environment and using that as the primary workhorse for leveraging and animating locators. But note that you can change the size, and you never, ever, ever, and this is kind of a hard and fast rule, want to scale a locator up and down. If you just want to make the cross smaller to make it easier to work with, just go into the display tab and make the size values smaller. Don't touch the scale, okay? That's dangerous. And of course, you're always willing to make a fancy label. You can offset it. Fancy label. I wish they would give us the ability to make the text a little bit bigger, because that's kind of hard to see. But it's, at the very least, it's nice that it's there. Okay. Questions about working with locators? We're going to be doing it a lot. Okay, great. Let's move on then. Let's get rid of some of this stuff. Actually, you know what I think I'm going to do? I'm just going to revert my project file back to the starting location instead of having to delete all that stuff. Great way to kind of get it back to its defaults. Okay. Now that we have a little bit more understanding of the parent-child relationship, let's expand upon this. The parent-child relationship is the most simple relationship that we can create inside of Modo. And as we just explore, the parent is going to drive the transform of the child. Well, what if we wanted to zero in and only drive one portion of that transform? What if we only wanted the position of one element to influence the position of another, and they completely ignore the rotation? Or vice versa. What if we wanted to have the rotation of one element drive just the rotation parameters of another? Or we can even take it one step further and have the position of one element drive the rotation of another. Okay? I mean, there's a lot of combinations that we can instantly create, all thanks to the lovely and very powerful constraint system that we have here in Modo. The constraints can be easily applied and very quickly applied inside the modifiers tab. It's right here, modifiers. And you can see the second, oops, I apologize. The second category is all of our constraints. Now, we're not going to go through all of these, but there are some in here that are worth kind of pointing out. We're going to start our day with position. Okay? The position constraint is going to do some really interesting things. And let's kind of define what those interesting things are. First and foremost, let's do this. I want to get rid of my arrow by deactivating it, and I'm going to grab my small target here, and I'm physically going to move it to a different spot within the scene. Okay? I want to apply a position constraint. The position constraint is going to basically put the center points of each one of these objects precisely on top of each other. The center point of the child is going to move to the center point of the parent. Okay? Let's just do it real fast. We still get 100% control over the rotation of each one of these elements. So here's the child. We'll select that one first. Hold down the Shift key, select the parent. And now, check it out. We're going to enable a constraint. Once two elements are selected inside of our scene, these constraint options become available to us. Note that there are a couple other different types of constraints nested in these buttons. Specifically, we can begin to only do position, or we can do a scale constraint as well. We're going to start with position. All right, let's do it. Boom. Now, I didn't move that element back to its starting location. The computer automatically did that for me. Let's analyze what's happened, because some things have changed inside of our item list. Some new elements have popped in that we need to be aware of. Now, based on the vertical hierarchy that you see in the item list, have we created a parent-child relationship between the big target and the little target? No. If you look at the hierarchy, they're all the exact same level. And the easiest way to decode the levels, just look at the little dotted lines. Okay? It behaves very similarly to a folder hierarchy. But there's some new stuff in here. What's new? That little plus sign. Let's explore. That little plus sign, and remember, the little target is the child in this particular situation, is going to contain the actual constraint. So a new piece of UI for us, the little gear icon. We're going to be seeing these a lot over the course of today and especially next week. That little gear icon is the UI for a constraint. It's always going to give this the name of the constraint that's been applied and what this element has been constrained to, in our case, big target. Let's go over to our Properties tab. Okay, so if I try to move this thing, am I going to be able to move it? No. No. Okay? The big target is overriding the entire system. So if I move the big target, check it out. Okay? Now, instead of having to move two elements simultaneously together, I get to move one, and everything that's constrained to it will come along for the ride. Okay? The big thing to note about working with the position constraints is that it's going to physically move the center point and all the associated polygons of the child to the location of the parent. It's going to do it automatically. They're going to share the same position. Okay? It's overriding the transform channels of just the position for our child. Okay? And as you just saw, I try to move it. No dice, because all of these values in here are being driven by the parent. We can still rotate. The rotate values are still live and in effect, so yay! Love it, okay? We can still scale it up and down, which is kind of neat, okay? So the only thing that's being overridden at the moment is the location of the position values of the transform. Okay, one other thing, and this is actually kind of neat. The item list at the very top, oops, excuse me, let me collapse it. In our scene file, we also have an additional little plus sign. This plus sign, when expanded, is going to show you all the constraints that have currently been applied to our scene. Because often it's very difficult to boil down and expand an entire complex hierarchy to find one constraint, right? When we start doing characters, our hierarchies are going to be like 20 layers deep, okay? They're going to be pretty intense. Having to go open up all the disclosure arrows to get the constraint on the toe piece is going to be a monumental kind of workflow killer. Yeah, so having a little list at the top is a big help, okay? Now, we added a constraint by clicking on the button. One other thing, and I apologize. If you click on the constraint, we often are going to get a whole series of additional channels that this constraint is going to use to manipulate our mesh. For the position constraint, we have some offset values. So, for example, I can go in and offset this on the Z. Yeah, rock and roll. So we still get a lot of control. Note, can I animate that offset value? Yes. What tells you that I can animate that offset value? Little circle. Okay, the little circle indicator says, hey, you can keyframe me. You're going to find that almost every single channel inside of Modo is animatable, which is, yay, that's thumbs up for rock and roll. We really, really like that. Okay, so we're always going to have some additional channels inside of our constraints that are going to allow us to customize the behavior of this strength. Okay, let's put that back down to 0, and we're on our way. Okay, we added a constraint real easily by going over to our constraint menu over here, but unlike the setup tab, here's the parent relationship, and there's an unparent. We don't get an unconstraint, if you will, inside of this, the modifiers list. How do we delete a constraint and remove its influence? Yeah.
Delete it right out of the object.
Yeah, the item list. Okay, we got to delete it from the item list. Let's go over. I'm in the item list now. I'm just going to right-click and choose delete. Boom. Okay? And now, look what's happened. My little ring has returned to its original location. And it still has preserved the input value that I put in there initially. Constraints are a fantastic, and I mean a fantastic way of creating meaningful relationships between a number of different elements quickly within the scene itself. Okay. Now, the position constraint, real easy to work with, but there are a couple other constraints that I want to draw focus to. Let's talk about the rotation constraint. As one might imagine, instead of, so we're going to do that one. There we go. As one might imagine, so child, parent, let's add the constraint. Boom. Get a little piece of UI that makes a visible on-screen connection between those two elements. As one might imagine, the rotation constraint is going to override rotation values. Okay? Now, I can have one object influence the rotation of many inside of our scene. If we analyze the details and the additional channels that are added into our rotation constraint, you can also see that we have offsets. So maybe I have this guy completely 90 degrees offset from this one. So we can add some organic movement in there, which is pretty neat. You can also, if we take this one step further, let me go back in time here a little bit. Get rid of that offset. There we go. We'll talk about that here in a minute. Okay. Now, so we're taking the rotation of the center point of the parent, and its values are being fed over to the rotation values of the child. Okay, so that's what's going on in here. Pretty neat. The direction constraint works a little bit differently. Okay, let's delete this guy. And let's restore these rotation values to the original. Okay, so now they're perfectly rotated, or they're positioned in their original orientation within the scene itself. Okay, so let's talk about the direction constraint, because position constraints and rotation constraints are pretty straightforward, not too complex. But things start to get a little bit funky and a little bit weird when we start enabling the direction constraint. Okay, this is actually one of my faves, and it's pretty special. Let's explore what it looks like when we apply the direction constraint into the mix here. Okay. I think this probably could be best illustrated if I do, let's turn the arrow back on, all right, and let's do this. Let's, yeah, we'll make a direction constraint from this feller here to that one over there. Now, what I would like to have happen here in this particular situation is the arrow to always, always, always point at the circle, okay? I don't necessarily need the arrow to move, but I do want it to point at the circle, wherever that circle goes inside of our scene. Let's create the relationship. Which of these two elements do I need to select first? The child, which in this case is going to be what? The arrow. You got it. So let's select the arrow. And now I can hold the shift key and select the little target. Let's add the direction constraint. Now initially you're probably going, what? What's going on here? Let's move the little target and see what we have. Let's test our rig, and hey, look at that. It's actually kind of working the way we would like it to work, okay? So if I move it over there, life is good, okay? Let's explore specifically what's going on. If you look very, very carefully here, the center point for my little arrow has rotated itself along the positive z-axis to look precisely at the center point of its parent, in this case, the little target. So the center point of the child is looking at the center point of its parent, okay? So we're overriding the rotation values, but we're not accepting the rotation values of the parent. I can still rotate that parent no matter, as much as I want, right? The center points are kind of in alignment now, and they're always going to look at each other like this, okay? Let me illustrate that concept here for you real fast. Take a step back. So I can just rotate this bad boy as much as I want, okay? So the rotation of the parent is not in any case influencing the rotation of the child. The position of the parent is influencing the rotation of the child. The directional constraint. The direction of our center point is going to match the direction or the location of the parent. It's a little bit backwards at the moment. It'd be really nice if the tip of the arrow was looking at my target over here. That'd be lovely. So let's look at the direction constraint properties and see if there's some channels in here that will allow us to change the way this constraint is behaving. Based on what you know about computer graphics, which of these values should I initially explore? The axis, absolutely. Let's go back to the OpenGL viewport and analyze what we see and make a cognizant connection to that value right there. Default's on Z. If I go back over here and look at my arrow, which axis of our center point is going down that purple line? The Z. So what if I change it? What value should I change it to? X. Let's see what happens. Let's go back into my constraint, change my axis value to X. Boom. Didn't have to rotate it, because I can't in this particular situation, but changing the values allows me to get the precise control of what I'm after. And now that arrow is always, always, always going to look at my guy, no matter where I place it within inside of my scene. It's pretty great. It's pretty great. This is, in essence, how we're going to have the turret behave a little bit later on today. It's pretty great. Yeah, I like constraints. Constraints are a whole lot of fun. Okay. You can also roll it a little bit. There's some fun values in these constraints that you just need to kind of look towards, okay? Not all of these you'll need to change or leverage as we go through this process, but check that out. We can even offset it a little bit, so we can give it a rotation value. That's on, maybe we have this rolled 45 degrees. Now it's always going to be at a 45-degree angle. I mean, these are the types of controls that we just absolutely love. Got to add sound effects. Got to add sound effects. Life is so much better when there's sound effects, right? Okay, so pop quiz. How do I delete my constraint? The item list. You got it. Let's delete it. All right, and then it goes back to its original configuration. Let's reset the transform here. Oops, meant to do reset all. And now we're back to the original starting point. Let's talk for a second about flow of information, because I think probably the best and the easiest way to kind of illustrate what's happening here is to understand how all of these values are transitioning their information to the elements that they're connected with. Last week when we started talking about the rigging universe, I drew focus to the bottom half of our setup tab, which is called schematic window. And I actually happen to really enjoy the schematic. I think it's a whole lot of fun. Before we get there, let's just do, let's do a simple rotation constraint between these two elements. So I want the rotation of this guy to influence the rotation of that guy. How do I establish this connection? What's the first thing I gotta connect or select? Excuse me. Remember, I want the rotation of the arrow to influence the rotation of the ring. Circle is going to be the child, so we select him first. Hold down Shift, click on the arrow, and let's do a rotation constraint. So now, when I rotate this, it doesn't matter which values, it's influencing its child. Rock and roll. This we discovered. Let's talk for a second about how the schematic window can come into play here to help us visualize this entire relationship. The schematic window is a nodal work environment. We'll be able to import a number of items, visualize their channels, and more importantly, see the flow of that information from one channel into another. It's really easy to see this inside the schematic window. We're going to be working with the schematic periodically throughout the semester, and I just want to illustrate what it looks like and how this nodal work environment works for us. Let's check it out. I'm going to take my little arrow, and I want to drag it down into my schematic. Boom. And you can see that we have a little node here. This little node gives us an arrow, or excuse me, it gives us a couple indicators. The first thing, obviously, it's going to show us that it's a mesh item. It's going to adopt the mesh item name that we're used to seeing in the item list. And then down at the bottom half, we have some dots. Okay? These dots are inputs and outputs. The back end of Modo is just a whole bunch of computer programming code, right? It is data. Everything flows from one item into another. These inputs and outputs illustrate that flow of data from one item into another. Now, one of these dots looks different from the other. What's the difference? One's yellow, okay? Whenever you see a yellow dot, a yellow I/O node inside your schematic, that's telling you that there are additional channels that are influencing the world rotation channel of my arrow. You just double click on it. It will automatically load the element that's influencing that value. And should be no surprise, the thing that was loaded in was the rotation constraint. Got another little yellow dot over here. That means there's additional information that's at play. Let's double click on it and check it out. Now we can visualize and plot the flow of information from one element to another. Just look real quickly, and hopefully you're following along. Look real quickly at that rotation constraint in the center. It's got two channels. It's got an input channel and an output channel. If we follow the flow of information, the arrow is exporting all of its rotation information, and it's sending it to this little input here. This constraint is going to process that data, and it's going to send all of that value to the world rotation of little target. Pretty neat. Pretty neat. Good way to visualize the connections, but it also gives us an environment to change the way this data is being flowed from one element to another. Now, world rotation is a composite at its default, but it's actually a whole series of values. Let's just get all this stuff in here. There we go. Rotation Y, do rotation Z. Okay. So instead of using the composite, the world rotation values of that mesh, what if we use individual channels of our arrow to drive the rotation of our little target? This is the power of the nodal window. We can change the way these constraints and the way the information is being flowed from one thing to another just by adding additional channels in here. Now for our little target, I'm going to go over to my Channels tab, and let's just grab all three rotations, and I'm just going to drag it in there. Let's open it up. Okay. So instead of sending information to the world rotation composite values, what if we specifically target rotation Y? And as a reminder, I'm not sure if I can do this right now. I won't. Rotation Y is this axis. So it's I want my thing to spin like a top. Okay. So I want to have the rotation. I'll do rotation. What do I want? I want rotation X to influence the rotation Y over there. So check it out. I'm going to break the link, okay? The rotation X values go into input. Oh, it's not going to let me. It should let me do that. Oh, I know what it's looking for. This may be one of those things that they've changed, and I wasn't aware. Here, as an illustration, I want to add something in here that's really kind of super. Yeah. There we go. This matrix channel effects will allow me to. There we go. That should work. I'm surprised that's not going there. See how the nodes are going red? Let's see if that works. If I drive this one, rotation X, let's see if it works. Nope, not yet. So I messed it up. Let's get rid of this guy. Delete that node. I thought it was matrix channel. Yes, here we go. There we go. Now I'll take rotation X as my input. And that should be influencing the world rotation. And let's do the exact same thing on the other side. These matrix constructs allows us to take any 3 individual values and output them as 1, which is what the rotation constraint is really looking for. So now, almost there. Okay, great. I'm going to do the exact same thing. I'm going to add under channel modifiers, matrix, oops, not matrix compose. There we go. So we want the output of this to be the input of, oh, still not letting me do it, which is a bummer. Oh, I love it when they've changed things on me. Now I'm hell-bent on trying to, maybe I need to do matrix transpose. No. I love that they've actually given us defined, no, you can't do that, and yes, you can do that. Red and green really go a long, long way. I'm happy to see that, actually. Kind of defines the flow of information a little bit more intelligently. Let's just see what happens if this, when I link this in together. Nope, still not working. Okay, well, anyways, that was an epic failure of monumental proportions. I was just truly doing this to illustrate how we can change values. And now I've added all these elements that I got to unwire. Let's delete them. Let's also delete them over here. Yes. Now we can take just world rotation to input. Let's get it back to what we had before. And everything works. Everything works. I really wanted to go there, though. But that's okay. Nodal window. It's a nice illustration of how all this data flows from one element to another. I apologize for it not working the way I initially wanted, but I hopefully kind of get an idea of its value. It allows us to change the behaviors and create very, very complex behaviors. When we get to the particles and dynamics portion of this course, the schematic window is going to be our home away from home. It's pretty neat. Okay, anyway, let's keep cruising because I'm wasting time here. All right. So we've talked about the position, rotation, and direction constraint. Really quickly, let's just delete the rotation constraint from the mix here. Okay, there we go. Let's go up here, and we're going to reset the rotation values. My little arrow, and now we're back to where we were before. One other thing that's kind of fun, right below our directional constraint, we have this vertex position. And if we click on the button, you can see that there's actually a whole series of them. There's vertex position, edge position, and normals, polygon position, and normal. It's pretty cool. Let's explore this just for one brief minute, because this is actually one of those additions to our modeling workflow that can be quite advantageous. Okay, check it out. I want to make on a new mesh item, I'm just going to draw a funky, not a text element, I'm just going to draw a real quick shape. And I'm drawing polylines. Let's draw polygons. Come on. There we go. Wonderful. Okay. Check this action out. This is actually kind of neat. What if I wanted to have, on this particular mesh, the center point for my arrow be precisely constrained to that vert right there? And I mean precisely constrained. Well, this is the power of where this vertex position constraint comes into play. Let's do our normal selection as we normally would. That's going to be the child. That's going to be the parent. Comes on grade and pops it out right there. Now, on the surface, you're probably going, Pat, this is not working. I wanted it to go to the vertex over there, and I can't select a vertex when making the constraint. This happens at the item level. All rigging happens at the item level. How do I tell my arrow where to go, or to which vertex it's supposed to go? The properties. Let's check it out. Index value A. This is pretty neat. Okay. If I change this index value, my arrow is going to continue to pop around. And there it is. It's on index value 0, which was probably the first one that I created when drawing this shape. Awesome. So now, wherever this guy goes, my little arrow will also go. And now it's sharing, and look at that, that's pretty rad. It's just driving the position values. Vertex position. Now, there's a couple other things in here. I'm going to undo until all these are gone. Here we go. One more. There it is. This is actually kind of cool. We'll do the same thing again, but this time, instead of constraining the vertex position, let's do polygonal normal. Yeah. There we go. Let's look at its options. Why is it not updating? Did it rotate it? Let's see if it rotated it. Oh, I know why it's not updating the way I thought it was. The center point for this polygon is right there. So it's actually doing precisely what I wanted it to do. But now, this bad boy is only grabbing the normal, so the surface direction of my polygon. Because all surfaces inside of Modo have a defined direction that's developed by the surface normal. So the rotation of this arrow is being driven by that line. So a number of different things inside of the Modo system that we can hook together. Really cool for modeling. I've used these guys a couple of times. It helps tremendously. If you look at that list, you can also see that there are some other ones in that category that's kind of neat. Okay, there we go. There's also edge, position and normal, vertex normals. There's a lot of fun things. Just new ways for us to make meaningful connections inside of our scene. All right. The last one that I want to talk about real quickly is the path constraint. Path constraints are pretty rad. Love it, love it, love it. Pretty neat. But we have to generate a path first. Now, how do we generate a path? What is a path inside the Modo world? Anyone know? Set of points, but what type of points? Because it's a very specific type of point. It's a curve. We have to have a curve, okay? Let's revisit real quickly where we find and where we can go to create some curves. Yeah. We have all of our modeling tools at our disposal here. For a number of reasons, this is one of those reasons for us to generate a curve inside of the setup window. I'm on a new mesh item. Notice the center point for that new mesh item. And we can find our curves nested inside of this part of our basic tools tab. So they're inside the same button as the pen tool. We have the curve tool, the Bezier curve tool, and the sketch tool. There we go. I'm going to start off with the Hermite curve. I'm a big fan of Hermite curves. Hermite curves are the most basic type of curve that we can create in most all applications. They kind of go back to the original old school way of trying to figure out mathematically how to draw a curve, okay? How many points do you need in order for us to draw a curve? 3. You got it. So if I was to create 1 point, it's just a dot in space that's chilling, hanging out. I click again, now I have a straight line. But the moment I add a third point into the mix, it's going to start to create a curve in between those straight lines, okay? I like Hermite curves because it allows us to very, very quickly flush out some basic, simple shapes. Hermite curves inside of Modo are incredibly powerful. You're going to find Hermite curves supported in a lot of other types of 3D modeling applications. However, if you want a little bit more control, you might want to look at the Bezier curve. Like, for example, a lot of folks get confused working with Hermite curves. They think, oh, we can't make like 90-degree transitions. Well, you're wrong. You can make 90-degree transitions in straight lines. You just need to have more points, and more points closely orientated to each other. Like that. There it is. Okay. The more points that define your curve, the more sharp angles you'll be able to create. Okay. Some people, they don't like that. That's just way too much thinking for them. So here's what we're going to do. We can create Bezier curves, and the Bezier curves inside of Modo perform identically to the way the Bezier curve works inside of other apps. Okay? Oops, it might help if I turn the tool on first. Single left clicks. Okay? Now I have the closed function turned on. And we're going to get our tangent handles. Okay? We can even break the tangent handles by holding the control key down. The only big difference between the way the Bezier curve works in Modo in comparison to other applications is that the tangent handles are never truly broken. They're only temporarily broken. Check it out. If I go back to this one and continue to work with it, pops back out. So holding the control key will allow me to change things. So now we have a curve. Let's make it more curvy. Oh, one final thing. Notice that I've dropped my Bezier tool, my Bezier curve tool. If I re-enable my Bezier curve tool, do I get access to all those original control vertices that are driving this curve? No, unfortunately not. Can I still access and leverage the components that are creating this curve, the tangent handles? Yes. All curves are created by points. Points inside of Modo are what type of 3D component? Vertex. If we go to Active Meshes and turn on Show Vertices, you can see that we have all the control vertices still live and kicking on our little curve. We can go in Vertex mode, move them around, and continue to influence our curve even after the tool has been dropped. Pretty neat. I like that. It's a good thing about working in Modo. However, we don't get the uniformity of the tangent handles as we have before. So that's just something to be very mindful of. Now they are permanently broken. Yeah. Pretty great. So we still have access to all this info with Bezier curves. Hermite curve is a little bit different. If I create a Hermite curve and I drop the tool, if I go back into the Hermite curve tool, or I gotta select it, I think. There we go. If I go back into the Hermite curve tool, I get access to all these control verts. Just got to make sure it's selected before you get going. Hermite curves are kind of special inside of Modo. Turn off verts. Okay, let's go in and create a simple Hermite curve. And I want my little ring to go on a roller coaster ride. Have you guys ever been extraordinarily frustrated animating cameras inside of Modo? Or just getting something to follow a very specific defined path inside of Modo? Those days are gone after today. I'm going to show you how we can constrain an object to a path, like a camera or in our case, a mesh item. These path constraints are infinitely useful. I love path constraints. I've used path constraints to drive the movement of a camera. I've used path constraints to drive the movement of tank tracks. I mean, they are infinitely useful. We love path constraints. Okay? Yeah. Yes, with some love, with some help. But yes, absolutely. Now, the only thing that we're going to accomplish in the path constraint is that we're going to glue the center point of my ring on the path. Okay? Check it out. Let's do it real fast. I need to make a relationship between my ring and the path. So I'm going to select my ring, select the item that has my curve on it, which happens to be called mesh. And now, check it out. Let's do the path constraint. Let's go ahead and fire it off. Boop. Ta-da! And now, that little ring is on that path. I want it to animate along that path. Where should I look to go to find the values that I can change to make it move? What's driving this relationship right now? The constraint. So let's go look at the constraint itself and analyze its properties and see what we can see. Let me grab the path constraint in my item list and then check it out. All right, here we go. We have some fun stuff in here. Path percentage, this is our jam, okay? Path percentage is going to allow us to move this object along the path. Notice that its value is a percentage. 0% over here, 100% over there. So if I wanted to go from 0 or from start to finish, I got to animate the path percentage from 0 to 100%. Woo!
That'd probably be great if you're going to make something like vehicles moving along some terrain or something.
Yeah. If you ever need to constrain movement along a defined path, this is it. Now we have some additional properties in here that's going to drive the movement of this element. Let me stop my animation. A couple things to look at in here specifically. We have an offset value. We also have a wrap function. I actually really like this wrap function. If we put my timeline back to 120 frames of viewing, watch what happens when it gets to the end. It should, let's see, why isn't it going back? It should go back. Oh, because I have it, I still got to keyframe it. Okay, let's do this. At 60%, I want it to be, maybe I want it to go 3 entire cycles over the course of 60 frames. So if I do 300%, now it's going to repeat its movement. So there's the first one, and then it wraps back around and continues it. So if wrap is turned on, we can increase the path percentage more than 100% and have it repeat its movement over and over and over and over and over again. Do you guys ever wonder how they do like bullets and stuff?
So you can have it toward the path moves as well. So you can have it toward the path is stuck between 2 objects, and you can have it toward something like bullets moving along it.
Yeah, exactly. Because, you know, for example, maybe I want to have, maybe this is my little arrow here is a weapon. Okay, awesome. The ring is the bullet on that weapon. I could, let's do this. I could parent my curve to the arrow. Now, wherever the arrow goes, my path goes, or not. What happened there? I'm not in item mode. That's what was going on. I was in Vertex mode. There we go. So now, check it out. I can rotate that. The path is always going to stay in its appropriate position in relationship to the arrow. And that ring is always, always, always going to go down that path. It's a good old school trick for bullets, okay? Just to create the illusion that something's being fired out of the barrel of a weapon, you know, quickly without having to do like a particle simulation and all that jazz, because that gets quite complex. It does. This is the easy hack. Pretty cool, huh? A couple other things. Let me go back in time for a second. Remove the arrow from the mix here. Okay. Okay, on our path constraint, a couple things we need to be aware of. Of course, yeah, now we're back to square one with that wrap value. Okay, a couple things to be aware of. Okay, the axis that we're constraining our path, our object to the path, is important. So you can change it like this. Okay. There's also a roll value in here that's really, really attractive. I like the roll, especially when we're animating like, oh, I don't know, a spaceship or something. We can have things kind of bank into curves pretty quickly, right? Animating the roll, oops, not along that axis. Animating the roll can make it look like it's actually kind of flying, which is kind of neat. The path is taking care of the y-axis movement, and now I can animate the x-axis movement through this roll value. Up vectors are something that we're going to talk a lot about as we get into the character rigging component, but it's good to know that we can define what axes this object thinks is up. Return that to 0 and put this to 1. Now it's always going to try to point down, and a lot of its rotation parameters and what it thinks as the positive orientation in the scene is going to change. Roller coaster. Whee! It's a lot of fun. Okay, questions so far? No, everyone's good. Everyone's good. Everyone's kind of understanding the basics of working with constraints. Okay, let's take a break. Let's take a break. Okay. I want to go back just to D2L for a moment and just highlight inside of the alien invasion homework assignment sheet. I've given you guys this asset of the little spaceship I made a long time ago in a galaxy far, far away. No pun intended. Oops, looks like I have 2 copies on my desktop. Let's just get one. And it's just a model file, okay? But as you can see, I've been doing some kitbashing inside of Modo, and I've created a cool little turret that eventually I want to use as the kind of driving force for my project, for my homework, okay? So I have 2 different project files right now. I have my turret in one project file and my spaceship in another. Is there a way that we can combine both of these project files together? Yeah, there is. There's a number of ways that we can do this. Let's just check it out real fast. Of course, we have the file import button. File import. Don't do import reference. This is something completely different. Import. Let's go find the Loxology project file that we want to work with. There it is. Now you're going to get some options here. Or if it's other than a Loxology project file, you're going to get some options. Okay. There's my little spaceship. If you're importing an FBX, for example, you're going to get some options as to whether or not you want it to be a static mesh and what have you. Okay. Also note that it's pulling everything from that project file, so definitely want to strip out all of that information before you go forward. And I'm going to get it out of that folder too. Yes to all. Here's the spaceship out of that group locator. Delete that. And now we're on our way. Okay, we can begin to work with a little spaceship in a meaningful capacity. That's not the only way that we can work and import assets into Modo. Check it out. If you notice what's happening here, this is actually really kind of neat. Inside of this untitled project file, it's referencing the, hold on a sec. Nope, I misspoke. If you import it as a reference, it will include that referenced, here we go, let's do this. This is really kind of neat. Do file, import reference, and do spaceship. Now, let's do, of course we don't want the materials and shaders and the lights. And it should, yeah. See how it's got that little triangle next to it? That means that this is any change that we make to the original project file, to the spaceship LXO, will immediately be adopted inside of here. It's pretty cool. Let's check it out. Let's open that original spaceship project file. Great way to start to collaboratively working. It's already loaded as a reference. I gotta close down. Let me do Pat's turret. Hopefully this works. There we go. And I'm gonna close it down. We'll close all. Don't save, and then I'm gonna open spaceship. Now, any change that I make here, and let's just do a really wacky, obvious change. It's pretty obvious. Yeah, exactly. So if I save this, then I'll close it. Then I'll open up Pat's turret. Let's see. Yeah, that change has been adopted. Yeah, it's a great way for us to collaboratively work together on model files while still animating them at the exact same time. This is why we don't want to animate on side of or on an item. We want to animate on a locator if possible. Okay. Now, I certainly don't want my my spaceship to look like this. Oh, it's being overridden. How dare it? Maybe I do want it. Abort to prevent edits on reference. Okay, whatever. I really just want to delete you. Yes. Okay, it's not going to allow me to delete it. Here, fine. You know what? I win. I want to close you, start anew. I don't need you. You can't tell me what to do. All right, so we're going to do some kit bashing for our project this week. And kit bashing really allows us to take stock models, and I want you to use the stock models that you found in your Meshes tab. I'm in the spacecraft folder, okay, which I believe is under vehicles. And you're going to be creating a cool little turret. So here's vehicles, spacecraft, okay? Have fun. These are free models that are given to us by the guys, good old folks down at Luxology. Have a good time with this. Make a turret. And your turret does not have to look like anything. If you want your turret to look like a hairdryer, make it look like a hairdryer, okay? It really does not matter one iota to me. Just have fun with it. It's supposed to be kind of a fun, creative assignment. So I'm going to do some kit bashing here real fast. Grab that one. That was the base that I was using. When you double-click on any of these elements, it's going to be automatically imported and loaded into your scene. Huh? At the origin. You got it. Let's do something different. Let's do something less obvious. Everyone's like, oh, I just used that one. Done. No. Let's have fun with this. Sure, if that's what your turret wants to look like, I say do it, man. I'm in poly mode. I want to work with these in poly mode. You can't find it, Alicia? You got it? That's boring. I'm sorry, I can't understand you. They're being on what? Can you be a little bit more specific, Dylan? There we go. Okay, Dylan, help me out. What are you trying to say? Yeah. So this sounds like it's not a preset problem. Yeah, so it's not a preset problem, right? This is a texture locator problem. If it's not showing up on the mesh, you got to change the texture locator. Okay. All right, what I'm going to do here is, I don't know. Let's just put a couple of these in here. Oh, that's teeny tiny. That's no good. We'll just put this guy. This one's big. It's kind of fun. Spending way too much time trying to figure this out. I think I'm just going to go back to what I had before. There we go. Now, when you're modeling these things, remember, or when you're kit bashing here, pay real close attention to placement and orientation, okay? You just can't do this willy-nilly. There we go. That'll do. All right. I'm going to, the other way to open up a project file or to get something in, if you just do a straight open, okay? Let me just get rid of all this. Yep, cool. If you just do a straight open, here's the other way of very, very quickly combining objects, mesh objects from one project file into another. It really is as simple as drag and drop. Okay? You can drag the mesh from one element or from one project into the project file of another. Yoink, like this. You can get a little popover saying, hey, what do you want to import? I just want to do none of those, actually. There we go. And I just want the object. I didn't want any of its shaders. I didn't want any of its child objects. And there we go. Now I got my little spaceship chilling in there. Awesome. Okay. So as we had described earlier, the goal this week is really to try to create a whole series of rigged elements that allow us to animate the spacecraft and also animate the turret attacking the spacecraft, or at least tracking the spacecraft in the sky. So before we even lay down one constraint or one locator, let's conceptualize in our mind what this thing is going to look like, right? Because we can't build a machine unless we have a firm grasp and a solid understanding of what we want the machine to do, okay? So let's talk about how this turret is supposed to function, or how it's going to function for me. Let's go to the Setup tab. All right, I'm going to turn off my spaceship for the time being. It looks like I'm building this turret from two different items. I got the top piece as one. Yeah, there's one. And then the bottom and the base is another. Now, the base looks pretty stationary, okay? Except for maybe like right around in here on the base. This looks like a place naturally where it would rotate, or maybe starting at that cylinder right there. Yeah, that's wait, no, you got these support beams up here. So maybe maybe here, starting here and up. This is where the turret is going to rotate around the y-axis in my mind. Okay. So I want to have a couple different series of rotation in here, because the whole turret isn't going to move. I want the base to stay stationary, the selected polygons to rotate around the y-axis, and then I want the gun, obviously, to go up and down, to rotate up and down. Okay? I don't want the gun to rotate like this, because that would be bad, right? That doesn't look real. We want that middle section to rotate like a waist, and then the weapon to rotate up and down, to do the tracking vertically along the sky. So that's the big specification. That's what we're after here, okay? Now, we have to take a close examination of the model itself before we can start rigging it, right? Whenever we want to have things rotate independently from each other, what do we have to do to them? If we want something to move independently from the rest of the scene, what do we have to do? We got to separate it. You're absolutely right. We absolutely have to separate it before we can go forward, okay? So here's what I'm going to do. I'm going to create a new mesh item inside of my scene. Oh, looks like I already have one. Awesome. And I'm simply just going to cut those polygons from there into there, okay? So now I have three separate items. This is what I believe to be the top piece, and let's just name these. Let's just top. This is the base, and then this is the middle. Great. Okay, so let's start engineering this. First things first, though, we got to get all the center points lined up. Yes, ma'am. I just selected the polygons, went to the top of the screen, and I just did a cut, and then I pasted those polygons into a new mesh item. Okay. I'm going to go through and just kind of cruise through real fast in item mode here and try to figure out, yeah. Let's look at where all the center points for each one of my component pieces is residing in the scene. Pop quiz, where is the center point automatically placed? At what? At the origin, okay? The center point is always automatically going to be placed at the origin of the scene initially, okay? The user has to move that center point to somewhere else, okay? Now, we're working with models that were created from someone else, so that person may or may not have moved the center point. But looking at all of my pieces, I can see that for my base mesh object, center point's down here. That's pretty good. I think I want it down there. For the middle, check it out. It's in the default location, which is at the origin of the scene. And the top piece is also at the location, or the center of our scene at the origin. Now, for the base, cool, this works, right? Center point's precisely where it should be. But for the middle piece in the top, what should we do to those center points? Move them. We got to move them to where their polygons are really beginning to shine a little bit. So I'm going to turn off my base, and I'm going to start working with the middle piece. I'll also turn off my top, just so visibly we're not confused as to where it is. I want this center point, that guy right there, to be, yoink, right there, okay? Now, I could certainly go in and move it with a high degree of accuracy just by selecting the Move tool. You could even get it somewhat close, but this is really probably not the best way of doing it because there's always room for human error in this system, right? No likey, I do not want to have to go in and hand tune this. It'd be great if we could have the Moto rigging system take some of this work for us, okay? And there's an easy way of very quickly moving your center point to match a defined location within the scene. I want to hit undo. Go back in time. There it is. Now it's chilling at the origin of my scene. In GCOOM 402, there was a couple moments within the semester that I talked about the importance of the work plane. In the rigging universe, the work plane becomes a much larger player. I'm going to select the polygon at the bottom, at the base of the middle section of my turret. And I'm going to align the work plane to that polygon. A work plane, as we know from earlier conversations, is a snapping grid. It's an interactive snapping grid. What you don't see initially is this snapping grid's center point. Let's check it out. Let's align the work plane to the selected polygon. Work plane, align plane, work plane to selection. Now I have my work plane visibly turned off. Turn it on. There it is, okay? There's the work plane, and it's glued to that polygon. Now, one of the cool things the guys down at Luxology have done is that they've given us an option that's really invaluable to help visualize where the center of the work plane is currently residing. The Draw Axis command allows us to get an indicator as to the origin of the work plane. And there it is. So there's where our work plane is centered around. Now this is really great because now I can go into my center point, select it, and under the Setup tab, check it out, set to work plane position. This is automatically going to move any element. I just happen to have selected the center point to the location of the work plane's origin. Let's just utilize this button real fast. Boom. I love it. Life is good. Let's do that again. So I selected that bottom polygon. I went work plane, align work plane to selection. We can see it's glued up there. Now I'm going to go into my centers selection set, select the center point that I want to work with, and under my setup series of tools, I'm going to choose to work plane position. Note that there's also some other options in here. We can do rotation. We'll do that a little bit further on in the semester. Shoot, you can even do it now if you'd like. Boop. And then it changes all the rotation values, but you don't necessarily have to do that. I like having my y-axis point directly up. Okay. After we're done, and this is a chunk of muscle memory that you have to establish. Whenever you align the work plane to a polygon or something other something else inside of our scene, you have to reset the location of your work plane back to its original orientation. If you don't, seemingly on the surface, Moto is going to break. Okay, check it out. All of my orthographic views base their orientation on the orientation of the work plane. So if I look at my scene from, I don't know, let's say the top, that is not the top. Okay, that is not the top of my mesh. That's actually the bottom of my mesh. What if I look at my scene from the right? Yeah, everything's upside down. That's because the work plane has been flipped and orientated to a new location inside of our scene. Once we reset our work plane, then all of our traditional orthographic views, there's the top, there's the right, there's the bottom, there's the front. All of our traditional orthographic views are going to be at play here. Okay. So back in item mode, if I fire off item transform, yeah, now I can rotate this element precisely the way I want it to move around. Now we moved the center point of our item here. If you look carefully over at the transform, the computer's logged some values for the position channels in the properties tab. Do I want those values there? No. What would happen if I returned those values to 0 right now? Yeah, let's reset position. And now everything's down there at the bottom. So what do we need to do here? Zero it out. I want to 0 the position values for this item, which makes the computer believe that its current location is its resting or starting pose. All right, so we got the base working the way we want it to work. We got the middle piece working the way we want it to work. Let's get the top all ironed in. Okay, so we have a couple little challenges with the top that make it kind of fun. Let's get rid of the middle and the base. There we go. All right, so where on the top do we want? I don't want this centerpiece here. Let's delete that. Let's see. Where do I want this object to rotate around? Say again? I deleted that mostly because it. Yeah. And I think for me, I want this is a starting point right in there. These polygons, these loops in here is a starting point for where I want this item to be rotated around. Okay. In addition to orientating, or you know what we could have? This is kind of cool. We can base our selections off of compound selections. So I can select all of these, hit an L. Check it out. Now, that's kind of, I want the work plane to be positioned in the middle of all 3 of those circles. Okay. Now, if I align the work plane as, yeah, check it out. Look where it goes. Cool. It's in the middle, which is right in there somewhere. And that's where I want this element to be rotated from. So we'll go back to center points, grab the center point for the top item. In the Setup tab, we're going to choose Set to Work Plane Position. And there it is. Bam. That's what we want. Let's reset our work plane and move on. Okay. Let's test it real fast. Whenever you do any sort of rigging, you make a change, test it. Make sure it looks good before you move on. Okay? And that looks okay. It looks okay. Yeah, that looks okay. I think it's good enough for government work. Hopefully our turret won't be firing at the ground because we're getting some penetration here on the polygons. Hopefully it'll be pointed up, defeating the foes as they travel into its airspace. Okay, awesome. As we did with the middle section, let's reset and 0 out this item's transforms. Boom. Now it believes that its current location is its starting pose inside of our scene. This is a rig that's ready to go. Or is it? Yeah. So the top, we're going to follow the exact same system as we did with the middle section. We need to define where inside the top model we want this object to rotate around. Now, depending on how you've chosen to build your turret, it may be a different spot. Okay, so it's up to you to figure out where you want it to go. We start it with a selection, and let's just do it on this top one. Maybe I want my turret to rotate around the center point of these 2 little piston things here. And you get to choose where it rotates. And I'm just going to expand my selection like that. There we go. I'm going to align my work plane to that selection. If we turn on Draw Axis, we can see precisely where the center of the work plane is. Okay. Now, I'm not liking that one so much. So let's do this. Let's go back to what I originally had. You can even do this in edge mode too. It's not something that's only limited to working inside of polygonal mode. Let's align the work plane. There we go. Beautiful. And now we can grab the center point of that element and set it to the work plane's position. Once that's done, we can reset the location of our work plane and test the rig. Now, here's an interesting theory idea. If you look carefully at what's happening with my little weapons here on the top, I'm rotating them, but instantly I'm getting some really, really horrible penetrations on the top of the rig there, right? That's pretty bad. Even when I go back here, I'm getting some penetrations. Is there a way that I can fix this? I'm sorry, say again? Well, remember, there's nothing connected to the base, right? There's nothing welded there. Have what in between? That's definitely something we could talk about and something to explore. I think where my brain was going with this is that we can experiment with a different location for these center points. If we're having this object rotate around an offset value, we may get a really interesting idea. For example, what if I brought this down a little bit? What if I brought this center point down to somewhere kind of right around in there? Oops, I didn't. It looks like I undid. I didn't. When I was hitting undo, I went too far, and I forgot to zero out the position. Now, if I change the center point for that item, it shouldn't go flying off the screen, and it is, but that's okay. That's okay. I could always go back in component mode and move these where I want them to go. Somewhere maybe perhaps right around in there. Let's test it now. Now my turret's going to rotate around the kind of the top bulb. Interesting. I'm not getting nearly the penetration values that I was getting earlier. It's a little bit different result. Okay? It could work. So just experiment with it. That's what I'm trying to get you guys to think about. Experiment with it. You never really know what's going to happen until you try a different rotation location for your item. There is. We can create what's called a set-driven key that will define a start and stop point. We'll talk about that in the future. All right, so I'm happy with the kind of base setup of my little turret here. Things are looking pretty good. However, if I was to move the base at the moment, what would happen? If I was to move this guy, move the base, what would happen? Whoops. Not precisely what I want to have happen here, right? So what do I need to do to make this turret a little bit more functional? Parent. Let's start making some relationship between all these pieces. I want the base to be the root of this hierarchy. So the middle is going to get parented to the base, and then the top is going to get parented to the middle. That way, I can move the base, the entire turret moves. I can go up one level within my hierarchy, move the middle piece, and that moves. I grab the top bit, and that one moves as well. Pretty cool. All right. Rock and roll. Things are looking good. Okay, but we're still not quite done yet. We need to go in and establish a whole series of constraints that allow us to have a targeting system for our little turret, right? We want this guy to track our spaceship in the sky. Let's figure that part out, okay? Initially, let's just use a locator to simulate the movement of our spacecraft. Let's add a locator into the scene. And I'm going to call this target. So I want my my gun to follow this guy. Let's put it up in the sky and shoot. Let's give it a good display locator. Locator shapes, custom locator shapes, and let's make it, I don't know, what do you want? A rhombus. Rhombi are always fun. We'll align it to the y-axis. That kind of looks like a target. We'll make it nice and big so it's really easy to see. And I'll go back into my 3D items and I'll add some draw options and just color it red. so it's easy to see. All right, so that's my target. That's what I want my, my turret to follow in the sky, automatically. Automatically, okay? So walk me through the process of creating a relationship between that locator and that item. Direction constraint. You got it. Because I don't want my turret to move its position. I just want it to move its rotation values. Cool, huh? Let's do that. Which is going to be the child and which is going to be the parent? Turret's going to be the child, so I'll select him first. The locator will be the parent. Where can I find all of my constraints? Modifiers. And then specifically, I'm going to choose the direction constraint. And immediately you can see the result that we're gaining here. Haha! Pretty cool, huh? So if I was to move my target, yeah, look at that. Pretty cool. Pew, 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 pew. Kind of fun. All right, so we're getting there. We're getting there. But as let me do this real fast. I'm going to put some very simple animation on the movement of this locator, just so we can visualize some of the issues that are coming in front of us. So let's do position X at frame 1, and then on frame 60, I'll just arbitrarily move it to the other side of the turret. There we go. So now it's just going to move. Cool. Great. If we look at the animation, the top of my turret is moving precisely the way I want it to. The gun itself is rotating. But that base should probably be doing a majority of the rotation going this way, like the waist of the gun, right? How am I going to get that to work? You could? You could do a rotation constraint, but don't over-engineer it. Huh? It's already part of a hierarchy, so we can't reverse the parent-child relationship here. What if we did an additional directional constraint? What if we did a directional constraint from the base of, from the middle of our gun to the target? Let's go back to frame 1 here. Do the exact same thing. Child, parent. Let's do a directional constraint. Okay, so mission accomplished. It's moving, but is that the compelling motion that I'm after? No. Let me show you one additional thing. This is actually really kind of neat. With directional constraints, there's a powerful channel that we get to leverage. Let's open up the directional constraint for the middle item. There it is. If we choose add output objects or options, okay, you're going to get this opacity slider. And this is going to basically allow us to turn off which values the constraint is exporting to the base, to the middle item. Okay? So we get to choose which rotation parameters we want the constraint to influence on that middle item. In this case, I think we want to turn off X rotation. Aha, look at that. Immediately we can see that it's now upright. And we also want to turn off Z rotation. Awesome. Now, haha, look at that. Great. Starting to look a little better. We could also do the exact same thing for our little weapon itself. What if, let me animate this thing going down, I think. There we go. It's a little up and down movement now. Okay. Do I want the gun to be moving up or to be moving along the x-axis? Not really. The only thing that I ultimately want the gun to do is just rotate along like this, right? I don't want it rotating like this, and I don't want it rotating like this. So we can do the exact same filter that we did a moment ago on the middle section on our gun. Go into the directional constraint. We'll add output options. And let's see. I want to do 0 that one out. And we'll 0 out the Y. And now my weapon's only going to be rotating along the X. Pretty cool. And we're getting a very realistic, compelling movement now. This is the power of our rigging tools instead of Modo. We can very quickly prototype a movement that's accurate without a ton of different things flying around, right? All right. Questions, questions, questions. Yeah. Totally lost. On what? What can I help you with? Okay, let's go back in time then. Let me revert my project file to state immediately before I did all this. Okay, so here in my project file, I've already gone ahead and established the center points for each of my 3 pieces: the top, the middle, and the base. I haven't done any parenting, any constraint work. If you look at what we have in front of us, there's no relationships in this project file whatsoever, okay? So let's make some relationships. When I move the turret, I want all 3 pieces to move together as a team, right? Like our chain. Last week, when we moved that top link, the entire chain moved as well, okay? We're going to do the exact same thing. Let's parent all 3 of these pieces together. The base is going to be the driver of this relationship. It's going to be the root. So everything is going to get parented off of the base. Let's just do it real fast. I want to have the middle piece be a child of the base. So let's just create the hierarchy. The middle get parented to the base. Boom. And where's the top going to get parented to? The middle. You got it. Just like that. Now, if you look at what we have, you can select the base, move it around, and all 3 pieces work together as a team. Pretty cool. Let's create that target that will serve as the thing that we're going to fire, okay? Or the thing that we want our little weapon here to fire at. So I'm going to create a locator. And in my item list, I'll call this target. And just to make it easier, and really the only thing that I'm doing here, and the whole impetus behind changing the locator's shape, is just to make it easy to see. You know, because you guys are lucky, you guys are pretty young. But for me, that cross inside the viewport is really, really hard to see, okay? It's right there, so teeny tiny. So with it selected, I can go over here to the Display tab, and let's add some draw options. At the end of the day, I want my little rhombus to be red, so I'll change the fill color to a user-defined value. I'm going to choose red, a light red, somewhere right around there. Perhaps a salmon color, I don't know. And now, let me go back and select it. And now with that established, the Locator Shapes tab will allow me to create a custom shape for this locator. Custom. And I want it to be a rhombus along the y-axis. Let's look at it. It's pretty small. So I'm going to change the scale value here. Size it up a little bit. Now we're talking. Okay, that looks good. Something like that. All right. Miss Wood, what is the goal? Yeah. What is the goal of this relationship that we're trying to add? Sometimes whenever you're rigging, just think about what you're trying to accomplish. Don't think about the technology. Just walk through in your mind, okay, what am I trying to build here? What are we trying to build? What are we trying to, what's the function that we're trying to establish? Yeah, right? We're trying to get the turret to look at that target. That's the function. We want the turret to automatically track that little rhombus in the sky as we animate it flying through our space, right? The direction constraint is going to allow us to do that pretty quickly. As we explored earlier, the direction constraint is going to take the center point of the child object, in our case the gun, and automatically rotate it to look at the parent like this. So let's do it. Which of these two objects are we going to select first? The gun. You got it. So I'll select the gun because it's going to be the child of this relationship. I want the gun's center point to look at the target. I'll hold down the Shift key in the viewport and select my locator, my rhombus, and I'll make the relationship. And I'm going to do a direction constraint. Boom. Now, the locator doesn't change, but look what happened to my weapon. It's changing its rotation values. And if I move my locator anywhere in my scene, yay! Okay, awesome. In its most simple form, it's working. Yeah. Allison, and then we'll go Johnny. I'm sorry, Alicia, and then Johnny. Absolutely. Think of it like this. I mean, and this is the way my brain kind of processes it. The child is always going to look at the parent. Okay? That's the rule. The child is going to look at the parent. So if we had flipped the order here, the locator would always be looking at the weapon, right? We want the opposite. We want the gun to be looking at the locator. Not initially, though. Without that relationship in place, they're not moving together. The whole reason we're constraining these together is to make a meaningful connection between the two. Okay? Without the constraint, and I've just hit undo and have gone back 4 or 5 steps, there's nothing that's telling the computer to move the gun when I move my locator. We want that relationship to take place, so we got to add that constraint in. I want this element to look at that element. I select the child first, the parent selected. I want that thing to look at that thing. And then directional constraint. Well, yeah, so if I did the opposite, let's do this. Let's just test it. Now I've done the selection order reverse. What moved? The locator moved its orientation. This isn't moving at all. So if I rotated it, nothing would happen. If I moved it, then the locator is going to change. Going back in time, let's just reverse the order. Child, parent, direction constraint. Now we're talking. Johnny, and then Allison. If it turns the other way, okay. So we have to look what computer number are you, Johnny? It's in the top right-hand corner of your screen in the nav bar at the top. 14. Yeah. Okay. I'm going to take over for a second, Johnny. Let's explore this. Okay. So look at Johnny's gun. Here's his target way out over here in the distance, right? Let's look at Johnny's gun. Specifically, look at the orientation of the center point on Johnny's gun. The directional constraint is going to, by its default values, align the positive z orientation of that item to look at the parent, which is why your gun probably went flip, right? Because the positive z axis or the positive z orientation of your center point is facing this way. Let's illustrate that real fast, just so we can kind of see it in action. Child, parent, directional constraint, and it flips around. Okay? So here's my easy peasy solution. Okay? There's a couple things you can do. I would do this. Okay? Of course, you can just grab the center point and rotate it. And rotate it 180 degrees. Go. Hold on a sec. Yeah, that works, and then we can just zero out rotation. Let's see if that works now. It's going to be close. That one to that one. Directional constraint, and we're close-ish. I messed up on the orientation of that center point. Let's try this. There's one other thing that we can do. Oh, I see what's happening here. I didn't realize that was that. There we go. We have to be very, very, very super aware of rotation parameters inside the computer because it's going to potentially mess some things up. However, this is actually probably the place we need to start. Okay, it's backwards. It's very backwards. What if we go into the constraint itself? There is this negative axis that works too. So now instead of blasting and orientating the model to have the positive z look at the parent, the negative z is looking at the parent. And that seems to be giving us the result that we want. Make sense? All right. You're welcome. Ms. Wood, you get a question. Same question. Did you get it fixed on yours? No. What computer number are you? 9. All right. Yeah, you're in the right spot. Click negative axis. Whoop, there it goes.
So with the spaceship, could we do that thing like you did with the ring where it follows the pencil and then that'll track it as well?
Okay. Let's keep cruising. Let's keep cruising. So this is looking good. I like it a lot. Okay. Earlier, I mentioned and illustrated that at the moment this piece isn't moving when my little locator moves. Okay, I would very much like the base or the middle section to move in conjunction. So I'm also going to do a directional constraint from the middle to my target. Yoink. Now, when I move my target, everything moves, okay? But it's kind of tipped up, Yeah, I don't want the base piece to rotate back along its local x-axis. And this is where we get to determine which values are sent from the rotational constraint to the child. Okay, and this kind of goes back to the whole schematic I did. This is the constraint itself. Imagine this is the constraint. Okay, this is the object that's going to be the base. Okay, these are rotation x, y, and z. Right now, this is x, y, and z. Right now, the constraint, this is going to be the mesh, is sending its rotation values like this. All that data is being sent over to the rotation values of the mesh item. When we add those output options, we get to control which one of these values is influenced and at what rate by that percentage of opacity. And I'm going to turn off x. I don't want anything to go on the x, and I don't want any information to go on the z. Only the y information is going to be sent from the constraint to the child in this particular situation. So let's go into the constraint on the middle. And under its properties, we're going to add output options, and under the opacity values here, we'll just zero out x, we'll zero out z, and now the only information that the constraint is sending to that item is y rotation stuff. And it's just going to move and behave like it should. That's pretty great. I like it. Very nice. Great. You're you're more than welcome and encouraged to do the exact same thing for the top of your turret as well. Yeah. Do it again? Yeah. Okay. Go back in time for a second here. So if you look at the constraint at its default values, this is the function that we're getting. You can actually see it on what I would call the neck of this middle piece. It's all tipped back, right? Because the center point of that item is looking at the center point of the target, right? And it's above it, so it's tilting its back. It's tilting back, okay? Well, I don't want it to tilt back. The only thing that I want the middle to do is just rotate like a waist, okay? That's all I want it to do. The directional constraint allows us to add output options, and let's just go into mine, that determines which values are being sent from the constraint over to the mesh item, right? Since I only wanted to rotate around the Y, I can turn off the X rotation values and turn off the Z rotation values by removing the percentage of value that's being sent. Okay, so there's the X rotation value. I just turned it off. There's the Z rotation values, and I just turned it off by returning it to 0. By putting this value like 50%, now it's getting half of the value. So if the constraint is saying rotate 90 degrees, the mesh item is only receiving a 45-degree movement. Cool. Rock and roll. Things are looking good. All right. And now, pew, 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 pew. Cool, huh? I love it. It's a lot of fun. All right. So, last but certainly not least, and then I'll let you guys pick up the rest on your own. Okay? I want, let's do it from the back. Here we go. I want my little spaceship to fly like right here. Okay? How can I get the spaceship to perform a very predictable movement? Yeah, curves and a path constraint, right? We don't necessarily have to go in and hand animate anything. We can do all of this with constraints. So check it out. I'm going to make some curves on a new mesh item. Let's just call this space. That's not nice, space. Spaceship path. Go into our model tab, and under the basics, I'm just going to draw a Hermite curve. And then I'm going to path constraint a couple different elements. Okay? All right. So now we got to start doing a little trial and error here. Okay? Some trial and error. Oops. Drop the tool. Let's see what we get. And I want to move that element a little bit in front of my turret. There we go. Okay. So there's my curve. Okay. Where's my spaceship? There's my spaceship. Now, what am I going to do to my spaceship? My spaceship is just chilling down there at the origin of my scene. There it is, right? I want that spaceship to be constrained to that curve. How do I do it? You got it. So I'm going to click the spaceship first. The mesh item that contains the curve second. Child first. Parent second. Path constraint. And now my spaceship is on that path. How do I animate the spaceship going on the roller coaster? Yeah, the path percentage value in the path constraint, this guy right here, will determine where my little guy's going to go. All right, mission accomplished. And I can even use this roll factor to make it look like he's kind of flying. Awesome. I mean, there's a lot. You can have a lot of fun with that. You're going to have a lot of fun with it. Okay. Is there a way to animate which? No. constraints can't be, so to enable a constraint on and off, you can't do that. Yeah, you'd have to engineer a different system if you wanted it to switch midway through. Okay. All right, so how could I get, yeah. How to do the constraint itself, or how did I draw the path? Do you have a path drawn? So draw a path, that's the first thing, right? Paths are always going to be drawn on the work plane. I love it. Your spaceship's going to attack the turret, which is fine. It's an aggressive spaceship. There you go. Yep. Spaceship first. Yep. There you go. Ta-da! Good job. All right. So let's talk about what we've created so far. We have a system where my spaceship flies along a very defined path. We have a turret that shoots at a target. Is there a way that I can combine both of these systems? Kinda. We could try parenting. We could try parenting the target to the spaceship. Let's see what we get. So here is the target. I could parent it to the spaceship. I mean, yeah, it's gonna kind of work, right? Well, kinda not. That's out. So don't do that. Position constraint. There it is. Absolutely. Because we want to physically move the target to share the exact same location as the center point of our spaceship, right? I want the target glued to my spaceship. The position constraint is going to be our jam. Okay. So in this case, the target is going to be the child. Hold down Shift, grab the spaceship, and now I can do a position constraint. If we look over here, let's animate the spaceship moving along its path. Over the course of 60 frames, maybe it will go right there. Wonderful. Mission accomplished. Questions? Yeah. Absolutely. All right. So we got to get this little target to match the location of our spaceship. The position constraint is going to allow us to do that, right? Because it's physically going to move the position of the child to match the position of our spaceship. I'll select the target first, like that. Hold down the Shift key, select the spacecraft, and then I'll do a position constraint. And now it'll work. Let me animate the path percentage of my spaceship. There it is. The turret moves and it tracks the spaceship as the spaceship travels along its path. I did a position constraint. The first one in the list. The great thing about working with constraints, and the great thing about working with constraints is that these values are seemingly live. We haven't keyframed anything, right? The only thing that's been keyframed in my entire animation is the path percentage value that my spaceship is using to kind of go down its roller coaster ride on the path. Nothing else is keyframes. That means I can change things within my scene quickly without having to rekey. For example, I'm not too in love with the motion path that I've created for my spaceship. It's kind of linear, right? Well, with that polygon selected, I can return to my Hermite curve, and I can change these values. I can make a complete change to, there it is, wonderful. And now, everything will update. This is the beauty of working inside of the live kind of constraint rigging system. We want to keyframe as few things as we can inside of the computer. I'm going to create just I don't know, some simple placeholder pieces of geometry for some buildings. Okay, there's some points of reference in here as to what all this looks like. Okay, because sometimes when you're animating and you're establishing camera movements and what have you, it's difficult to see and understand the spatial relationships between all these pieces. Okay. So this is my urban metropolis, if you will. Let's give my little turret needs to sit on a platform or something, right? Be weird if he wasn't sitting on a platform. Okay. All right, and my spaceship's wee off over there. Let me show you one other really neat thing here that will give you creative options. We can't forget about the camera in this entire situation, right? The render camera is going to play a big role in how we communicate this sequence to our audience. The knee-jerk reaction is this. Take your camera, and let me turn the visibility of my render camera back on. Show cameras, and it's somewhere in here. Let's see if I can find it. There it is. Oh, I turned the visibility off. So it's just chilling down there at the origin of the scene. Let's go into item mode. I'll start working with my camera. There it is. It's very small. Let's make it a little bit bigger so we can see its icon. Awesome. Okay, so let's do this. Here's the knee-jerk reaction. You change. Let's make something here. I'm going to split my viewport. This one is over here is going to look through my camera, and let's find. There it is. Okay. There's my spaceship. Maybe I'll compose a shot that looks like this. So I'll have the turret in there. That looks awesome. Okay. Well, cameras, it's an item. Cameras can use this entire constraint system as well. Pretty cool, huh? Let's do this. I'm going to grab my camera, hold down Shift, grab my target. Let's do a directional constraint. Boom. Now, my camera is always going to look at my spaceship. Rock and roll. This is pretty great. Pretty cool. One less thing that I have to animate now. Okay. Shoot, let's continue the animation. I'm going to go back to my spaceship's path constraint, and let's just put its value at 100. I'm going to open up the dope editor real fast and move that keyframe down to, I don't know, frame 100 or so, just so we have a little bit more time to consume what's going on. Cool, huh? This seemingly is like rad, right? How many of you guys saw Cloverfield? Yeah? You guys like the movie Cloverfield? It's an okay movie. Okay, kind of Godzilla type movie, right? Shaky cam, right? Everything was first person. Shaky cam. Oh. And it was really annoying, right? It was really, really annoying. People got headaches with it. I know my wife got a headache when we watched that movie, and she had to leave for 20 minutes because She just had a headache, right? And it wasn't fun for her. It didn't bother me as much. First-person POVs, shots like we have here on the left, when combined with really fast, action-packed movements, can make people feel uncomfortable. They are good shots, however, to include inside the mix, especially if the movement of our spaceship is not too fast, which is the other mistake people make. Your spaceship's like a zipping around your screen. Slow down a little bit, okay? Slow it down some. Doesn't have to be super fast, okay? Okay. These are good shots to have, but maybe we want another shot. Maybe we want to break up our sequence into a number of different elements here. Maybe we want to have this nice little kind of tracking shot, but maybe we want to have another shot where it shows the spaceship coming like from behind one of the buildings, or maybe like a top-down shot. We get to be little movie directors here inside of Modo, and it is awesome, okay? This is one of the new things they added in 701 that I am just absolutely in love with. It's a whole lot of fun, and it makes creating complex sequences like this really easy. Okay, or rendering complex sequence like this really, really easy. We don't want to have just one shot. We want to have one movement, but maybe we want to have a series of shots that illustrates and communicates this movement from a number of different angles, just like they would do over in Hollywood, right? Let's do that. I want to add a new camera. Let's get our naming conventions quite good here. This is going to be Cam 1. And let's it's Cam 1, and it's going to be the tracking shot. We got Cam 2 down here, and I'm going to just reorder my item list to have this make sense. This is Cam 2, and this is going to be, I don't know, the building shot, just so we have some idea of its role. I want to change my OpenGL viewport here to look at Cam 2. We can also move it. Let's make its size bigger. Man, that icon size is teeny tiny. There we go. That may be a little too big, but okay. Let's find a pretty picture here that we can use. Please don't crash. Please don't crash. Please don't crash. Please don't crash, Modo. Ah! Gah! Save and save often. Luckily, what I'm going to show you can be easily recreated in just a couple steps. Unexpected exit. No, I don't want to do any of that. You anger me. Okay, let's just do it real fast. Yeah. No. What am I doing here? What am I doing? Okay. See, even your professors who seemingly know what they're doing make mistakes. I'm not going to create a really complex rig and a really complex setup like I had last time. I will create something very simple so you guys have a point of reference as to what in the world I'm talking about. It's pretty cool. We can do live camera switching inside of Modo now, and it's pretty great. Okay, this will be my environment. Very simple. Okay, and maybe I'll have my little spaceship flying around one of these buildings real quick. So this is going to be our set. On a new mesh item, let's create a path. And I'll have it start over here and then end over there. Awesome. That's the path I want my little spaceship to follow. Okay. Let's do this. Let's just, for giggles, we'll have this sphere be my spaceship. Okay. All right. Let's go over the Setup tab and start defining how all this is going to work together. Okay. So in item mode, I'm just going to do a simple path constraint here. There it is. Okay. Let's animate that path constraint. Path percentage. Animate that one from 1 to 100. We'll change that to 100%. Now my little sphere is just going to go woo like that. Here, also to make it a little bit easier to see what's going on, let's make this, put it in its own material. Here we go. Okay. And I want to have my camera over here. Let's change the position of this. I want to have my camera just look over here, I think. Yeah, that'll work. I want to do a directional constraint between those two. There we go. So now my render camera is always going to look at my sphere. Okay. Awesome. Looking good. Well, we can add additional cameras into the mix and do a live switch, a live animated kind of edit, if you will, of this entire sequence. Let's add a new camera. So let's just name things. Cam 1 is going to be the tracking shot. Cam 2, I'm not sure what Cam 2 is going to be. We'll play around with it. Let's view Cam 2. Let's figure out a good spot for Cam 2. Maybe Cam 2 will be of our scene over here. We'll have it be drastically different. So we'll see the spaceship coming around the backside. There it is, or that way. That'll be cool. Let's add a third camera into the mix. Okay, let's add one more. This one's not going to be moving, or maybe we'll have it moving. This will be Cam 3. It will also be, this will be a high tracking shot. Okay. This one we're going to place like up here and have it directionally constrained to my sphere. There we go. Let's check out what Cam 3 sees. Yeah, it's pretty cool. Cool. All right. And then, yeah, I think that's a good start. All right. So here's the cool thing. I've added 3 cameras. I'm not going to render out 100 frames 3 different times, right? I'm only going to render 100 frames. I'm not rendering 300 frames for this thing, right? But I can do a live switch and tell the computer which camera to render at render. Pretty cool, huh? Now we're kind of pretending we're like a broadcast studio, and we're going like camera 1, camera 2, take camera 3, go back to camera 2, take camera 3, take camera 1, okay? It's pretty neat. However, there's one small thing that we have to change, one element that we have to render, or to animate, excuse me, to make all this work, and it is under your shader tree. The default render sphere is going to give you some properties that we need to look at. Specifically, it's under the frame category. Check it out. Render camera. This is a new channel, and notice that it's animatable. Okay? So let's render or animate which camera we're going to ask the computer to render out. Render camera. Let's animate that bad boy. Okay, so now, and here's the other thing that we want to change. Okay? Up here, we're not going to preview Cam 3, we're going to preview render camera, which is pulling all of that information that we just keyframed into our OpenGL viewport. Okay, so I'm rendering that one now. Then tracking the motion. Maybe in right around here, I change the camera to the high shot. So it's Cam 1 from that keyframe until 35. And it cuts over there. And then maybe right around in here, I go back to like Cam 2. That's cool. Doing a live switch. And then we see Cam 2 for a minute. And maybe right about here when it's about to go off screen, we go back to Cam 1. Like that. And it'll take Cam 1 for the rest of the time.
Does it automatically keyframe when you switch camera?
It does. There's the auto key. This is a place where the auto key feature really, really shines. And within just a couple seconds, I've made a little sequence of shots that will render out. Pretty cool. Live switching inside of Modo. We just add cameras, we animate them or do whatever we need to do to that camera to make it all work, and then the value that we're animating is the render camera value under your shader tree of properties. So click on the red or the purple render sphere, frame, that's the one you animate. This is one of those elements that will help you communicate a complex movement to your audience. And to prove to you, huh? Let's find out. Just switched cameras. And somewhere right in here, it's going to, there, it switched again. It's going to curve around, and there it goes. Uh-huh. Well, if that's the way he wants you to do it, then I would suggest that you follow his directions. Let's put a HDR map in here. Sometimes that helps gives context. Not in this particular situation. It looks lame. A floating sphere with floating weird things. Yeah, kind of strange. Or maybe sometimes adding a shadow catcher helps. Probably not in this case. It did not make it better in this case. My 2-minute demos. Anyways, good times, huh? Too much fun for me. All right, questions on what we've talked about today? All right, let's just go over and check out what you're expected to build for this project. Okay, a lot of you guys, if you've been following along, have already done the rig or getting close to being finished with the rig. So, yay, good job. Some specifics that I want to make sure you guys animate and build for this assignment. Let's check it out. Okay, so turret from Mesh Library. So please, please, please make sure that you are using the Mesh Library. Am I going to limit you from building your own turret? No, absolutely not. But this is a rigging assignment. It's not a modeling assignment. I'd much rather you spend your time rigging and animating than modeling. But if you want to do it, yeah, do it, right? Okay, simple set piece for alien invasion, okay? You just can't use a whole bunch of floating cubes like I have, okay? Keep it simple. Give it some context. I've seen just about everything. I've seen an alien attack a city. I've seen an alien attack another spaceship with turrets on that. I've seen an alien spacecraft attack a desk where it was great. A little alien came out of a coffee cup, had a little turret guns on them, and so an alien was attacking an alien and kind of a silly. Be creative, okay? Be creative. Have fun with this. This is one of those opportunities to build a cool little portfolio piece that demonstrates your kind of rigging powers, okay? And the ability to communicate a complex sequence with very simple machinery. Bum, bum, bum. Materials and textures for everything. So your render is not going to look as horrible as my render is, okay? Materials and textures for everything. Rayu, yeah.
Oh, yeah, I'm creating the path, but I think it's just 2 points, and it's too long, so I can't see the bullet line on it, but it shows it.
Yeah. You may want to slow it down. Yeah, I'd say overwhelmingly the thing that people try, or the mistake that people make consistently, is that all of their elements move too fast in the frame itself. Okay, I know that these are spaceships. I know that they're supposed to be flying fast, but you have to give the audience an opportunity to consume the image, understand the movement, and make a connection to its movement spatially. It just can't go real quick, right? Slow it down some. All right. You're more than welcome. I'm unleashing the preset library on you guys. So use all the material presets. However, buyer beware. And I know some of you guys ran into this with the chain. Are shiny, reflective objects slow or fast to render? Very, very slow. Okay? So I hope that you guys keep that in mind when you're choosing your material setup for your scene. If everything is metal, it's going to take 10 minutes per frame to render this thing, okay? Go crazy. Go crazy, yeah. If you want to put some lumigons in there, I say, yeah, thumbs up, do it.
How long will it take to render?
Lumigons aren't bad. Lumigons aren't bad. It's definitely going to add an element in there. But it's not, yeah, it's not as bad as everything being reflective. Yeah. Huh? Yeah. Yeah. I'm live streaming today, so if you want to go back in and check out this conversation again, I'd encourage you to do so. Yeah.
Keeping the background in After Effects.
Yes, we'll talk about that for sure. For sure. Okay, other things that we need to take a look at. Rig, turret to position, rotate, and fire at attacking alien spaceships. Okay, so just like we did today. All right, so position, rotation, those are constraints that we did. Must control surfaces for all movable elements of the rig. Okay, we've kind of already built those. The only movable elements of my turret was the weapon itself, and we have a control surface for that. Okay, duration, 10 seconds. 10 seconds. It's a 10-second long animation. Plan out your movement before we get too much further into it.
How do you change the length of something independent of the animation so it'll do it through all frames?
I have no idea what you're talking about.
Like, if I go in and resize something,
Can you be a little bit more specific than something?
like, I've got a path that's really long.
Okay.
I want to shrink it down.
Uh-huh.
But I want to, but I don't want to change everything else when I do that.
So,
Because if I could the animation.
yeah. Yeah. Well, how did you make your path? So you're just trying to shorten the length of your path, right? You can go into vertex mode, grab the verts that control that path, physically make it small.
And then it will change every frame.
Go find out. Okay. Duration, 10 seconds. Frame rate of 24 frames a second. Okay. Animation must include at least one alien spaceship flying through, at least one. If you want to have an entire armada of alien spaceships attacking your environment, I say yay, that's awesome. Cool. Yeah, maybe. Maybe, but at least it would be awesome. It would be pretty fun. Animation, turret must track, rotate, and fire at incoming alien spacecrafts, okay? With everything that we've talked about today, you have the information that can make this happen. Final render frame size, 1280 by 720. At a pixel aspect ratio of 1.0. The final render frame type is going to be an MP4 from After Effects. Okay? With that said, let's just revisit After Effects super quickly. All right. Let's do this. I have a very short animation here. I'm going to turn off global illumination to make it really easy for this thing to render this bad boy. And I'm going to render it so it's going to go dark. Let's turn the directional light on. It's in a shadow right now, which is fine. Cool. Very dramatic. I love it. So we'll render, I think my animation ends on frame 100. Let's see how fast I can do this. Render animations from 0 to 100. Let's render this out. I'm absolutely going to put these in a folder, okay? Let's just call this render. Otherwise, I'll have 100 frames just chilling on my desktop. And this is going to be alien underscore. And we're off to the races. I'm not going to actually render all 100 of them, by the way, because we'd be here for another 5 minutes or so. I think I may only render the first 30. It goes pretty fast. It's only taking about a second to render each. How'd you guys like rendering your first assignment? Pretty good, huh? Not too bad? Not too bad? Yeah, you're going to be rendering everything in this class, by the way. There's not going to be a single assignment where you're not going to render something. Even our character that we're going to start rigging either next week or the week after, we're going to be rendering progress on that rig. Let's get it to the point here. Well, it's 30% done. Maybe we should just let it go there, the full duration. I wish it would tell me precisely which frame it's rendering.
I think the percentage is the same frame, isn't it?
In this case, it is, because I'm only rendering 100 frames. So that would make sense. I would love, if the guys at Luxology are listening to my live stream, it'd be awesome to know precisely which frame I'm rendering. Is that in here? Maybe I have to scroll down. That's probably what they're saying. Hey, Pat, scroll down. Well, that's kind of weird. Yeah, it does. Can you just be at the bottom all the time? Instead of me having to scroll down? That's lame-o. Lame-o. I'm done with Fluxology. I'm moving on. I quit. Let's just go to Maya. That'll be easy. I'll show you. If you guys ever start bitching and moaning about rendering, okay, I'll bring in my laptop, which has a full version of Maya on it, and then you'll understand how well you have it, okay? Yeah, I know. It's very different. It's very different. Okay, we're 2 seconds away from being finished, and then I'll show you. Let's see if I can crash Modo by launching After Effects while it's rendering. I would never in a bazillion years recommend that you do this. When Modo is rendering, or when anything is rendering, even After Effects, just don't touch your machine. Let it think, let it process all this stuff, and just be happy, okay? Yeah. Yeah. Or it finished. No, it finished. Modo's done. Okay. All right, so on my desktop, here's all my render frames. All 100 of them. Beautiful. Now, I rendered this at 24 frames a second. So really, I have how many seconds of animation here? What, about 3 and change? Just over 3, right? 24 times 3. Or actually, yeah. How many is it? I don't even know. It's the end of the week. My brain is turning into mush. Math at this point? No. 4 seconds? Yeah, it's a little over 4 seconds. You're absolutely right, Chevy. Okay. Let's import this in. There's 2 things that we need to look at in here once After Effects decides it wants to cooperate. Here we go. All right. All right. So if I make a comp out of this, per our instructions, what don't you see right now? Background. And let's see, what's the total length of my comp? It's 3 seconds and 9 frames. So it didn't grab the right frame rate. So here's how we got to change it. If you go back to your asset in your bin, right-click on it, and we want to go interpret footage. This controls how After Effects is seeing this asset on the back end from the kind of the technology standpoint. Let's go main, and here's what we got to do. Check it out. First thing, alpha channel. We're going to ignore the alpha channel. Whoop, what popped in? My background. In addition, it says, assume this frame rate. No, 24. So it's under, if you right-click on your asset in your bin, choose Interpret Footage, Main. We're going to ignore the alpha channel. And we're also going to not assume, I don't know why it assumes, I hate it when computers assume things, right? No, it's 24 frames a second. And then we'll hit OK. Now it's probably, let's see, it didn't update the, didn't update my composition. So let's do this. I'm going to just delete this comp, and I'll make a new one from these settings. Yeah, that's the right. So you kind of want to do this first. And now, look, it's 4 seconds and 3 frames. Rock and roll. Instead of 3 seconds and 8 frames. Yeah.
Wouldn't the 30 be good for video and stuff?
30 is great for television. Yeah, if you're doing anything for the broadcast world, for the television world, it's all 30. For film, it's all 24. I do 24 in here because it's 6 less frames you guys have to render. That adds up when you have to render 30 seconds of stuff. It's an extra 180 frames you don't have to render right there. Okay, questions. Everyone good? Everyone understanding? All right, rock and roll. I'll see you guys next week. Leaving on time today.